I'd like to address a few of the key topics when it comes to process selection and facility layout. I find it is kind of a little bit more engaging type material because we can really think about whether we're in an office environment or retail or manufacturing or services of any sort, how you organize the physical location of the processes, the people, the equipment, all of the resources really makes a big difference in how effective you can be in an organization. So while this topic often hits some material that most people have been exposed to before, it adds in some things that very few of us have ever seen before. So it's kind of a cut across the two. Now this is something that I expect that you've at least been exposed to parts of before, and that is that there are four general process methods, which when it says process, it's really thinking about how do you do what you do, whether that's service or manufacturing or whatever it is. It's what you do, it's operations management. How do you create that output, whether that output is a service or whether that output is a product or some combination of the two. And so it comes back to these four generic descriptions and often starts with job shop. And job shop is a term where we describe a furniture shop, for example, or a cabinet shop, or an auto repair shop, where we have a skilled person with generalized equipment that can be used in whatever manner is necessary in order to create the desired output. So you could come into a high quality cabinet shop and describe to that owner exactly the type of desk you want them to build and how tall and how wide and how everything and how many drawers and what type of wood and the whole dimensions of it, and that skilled professional then would be able to use whatever tools they have there in the facility and raw materials to make exactly what you want. And so a job shop is often defined by a very skilled tradesman, generalized tools, a very high cost per unit, and the unit of output is usually a single outcome. Now we could do the same thing with services, because a dentist, an attorney, a tax preparer, a haircuttery operator, barbershop, those would also be job shops. And so they can take their knowledge and equipment and apply them to whatever the customer wants to be created. But let's progress through these a little bit, and then we'll tie them all back together. Batch processing is often thought of as a progression from job shop, where instead of making one unit at a time, we create multiple units at the same time. So not in sequence like you would with a production line, but again, we're working on groups at a time. So people going into a theater all sit at the same time and the movie plays. That would be a batch process. Trying to think, if we were making cookies, we mix up enough dough to make 24 cookies, we put them onto the tray, we put the trays in the oven, and then we have a batch of cookies comes out. So they're made in groups. There's efficiencies to that by mixing it all at the same time, cooking it all at the same time, showing the movie once to 30 people. So by moving toward a batch process, we often see our cost per unit go down, but all of the units in that batch pretty much come out looking the same or having the same experience. So there's a little loss of customization, but there's a great gain in efficiency. Let's move a little bit further. Repetitive means that we have specialized resources that do the same operation over and over again. So it's almost like a learning curve, where since we do the same thing so often, we can have specialized tools and specialized lighting and specialized training so that we can be very efficient at that step. And then the product moves to the next step and very efficiently receives that treatment. So we might look at something where we're casting something like with molten metal, and then we have specialized machine to deburr it, specialized machines to sand it, to sandblast it, to polish it, to apply paint to it. And so then each of those technicians would do that step over and over and over and over and over again, and it would be very efficient on a unit by unit basis. What repetitive allows us to do that batch doesn't is the batch size for repetitive can often be 1 unit. And so if one unit needs a special color like green, and the next unit needs to be purple, and the following unit needs to be blue, then that works really well with repetitive, but you can't do that in batch because they'd all be the same color. Continuous is really the ultimate in low unit cost. And continuous is very rare in operations. But continuous would be something where the output is exactly the same. So it would be like producing white bread flour, or white granulated sugar, or brown sugar, or gasoline. So it's a process that is often defined by very expensive equipment, very little labor content, and the equipment can basically run 24 hours a day, 7 days a week, and just continually just produce output. But the output is indistinguishable from its other units. It's just constant. It's the same. Now, rather than just putting these in a box and saying, oh, if I go into Jiffy Lube, this is what I experience. Is that job shop? Is that batch? Is that repetitive? Or that continuous? Or is it a combination? I would, just as Jiffy Lube, I would say it's almost a combination of job shop and repetitive, where you come in and you're treated as a single unit, but there's a person down underneath in that pit, and they're repetitive. They just go from pit to pit and drain the oil out of the car and put the new filter on. So they are very efficient at that single process, very well trained. They have exactly the right equipment to use, but they can go back and forth between 3 or 4 pits possibly. And so you get the benefits of repetitive, and you get the uniqueness of a job shop where a person can pull in with their car and say, well, I want the oil changed, the transmission changed, and the windshield wipers. So you can choose which operations to do. But let's not just think about, I think it's easy enough that whatever operation we could go into, we should be able to identify which aspects we're witnessing. But down here at the bottom, think about them from the standpoint of volume and cost and variability of inputs, outputs. And as a progression, if I'm an accountant and I do tax preparation, that would be pretty much a job shop. But the problem with a job shop is that the unit cost per piece is relatively high. So how could I turn my tax preparation center into something that is batch or maybe repetitive, because that drives my unit cost down? So I could buy specialized software. I could train individual people to do different parts of the process, and they could become very efficient at processing that step, which would allow me to increase my throughput and at the same time lower my cost per unit. That would be something that would be really good. So we look at how we could adapt our operation to move from being something that's particularly inefficient but flexible to something that is still somewhat flexible but extremely efficient, which leads to profit. So try to think about this beyond the basic definitions, but how we could transform an operation from one method to another. The other side of this is what we call layout, and there are some generic physical designs or layouts of processes. And look at the first one here, repetitive. That's often for a product. It can work with a service, but we call that often a product layout. And watch for this as you do any of the readings. It's become quite popular to use a U-shaped layout instead of a straight line layout, because a straight line layout often is limited to the physical distance of the organization. It's an assembly line. And one of the benefits of a U-shaped is that the product is always in sight of all of the operators. So if something goes wrong, it's easy for the operator to turn around to the person behind them and say, hey, what's going on? I'm getting bad product. So the communication flows are different. So there's many, many advantages of a U-shape, but we're seeing that transition to get out of assembly line mode. And you might think of Chipotle as a repetitive or not U-shaped, but a product-oriented, where it's handed from station to station, and that each person becomes quite adept and skilled at one step. Non-repetitive processes are often things that will move from department to department. So we might, if we're making, let's say, cookies, we'll go back to our cookies example, we might have a mixing department, and then we might have a cutting department, then we might have a baking department, and we might have a packaging department. So we often see those type of layouts as departmentalized, and then for any given product that you're making, you can decide whether it has to go through all the steps or only selected steps in the process. Fixed positions, fixed positions, very unique. That is where the workers have to come to the product. So think of that as a building or a ship or a large airplane where you can't move it around through the different stations. You actually have to have the people come and pour the foundation, put up the framing, put in the insulation, put on the sheetrock, install the carpet. So each of the specialized labor have to bring their equipment with them and then do their work on site, which adds a whole bunch of complexities related to scheduling. And then of course there's many different combinations of these, but again, what we're looking for in the midst of all this is what's the right blend, the best blend for either the product or the service that we're trying to create. Cellular I threw in there at the end, and I actually got to see a cellular manufacturing cell at one point. Very interesting, because what they had done is installed a small version of each of the pieces of equipment in almost a cubicle or a small booth where a single operator would deburr, grind, polish, apply the finish, and package a cast gear. And the benefit of that is it's very efficient, because they load it in the machine starts running, load it in the next machine, and so it's just a constant flow. The person's always in action, and they're able to do part family, so I could do all gears, or I could do 10 of one size gear and then 10 of another size and 5 of a smaller one. And so it just gives you a lot of flexibility, and it allows the person that's operating to develop a lot of expertise. Service layouts are often adaptations of all of these, but think about how you want your customer to flow through your process. In retail, that might entail where you locate the cash register. You may put it at the very front of the store, or you may put it at the very back, so you intentionally want the customer to wander through all the aisles and they may pick up other things. So it depends upon if you're rather a boutique store where you want the customer to kind of pick their way through and maybe find things they want, or whether you're a grocery store where you want the customer to go in, gather everything they want, and you'll check them at the door. So those types of things. Last topic is line balancing. Think of this first from the standpoint of an assembly line. This does not, this process, line balancing, works very well in services, but it is easiest to learn when considering a product, an assembly line in particular, where a product goes station to station and has work done on it and then is finished at the end of the line. So look at line balancing from that perspective, but then I will challenge you to think about it. Okay, what if my my assembly line is actually a bank, and I want customers to come in the door and receive and sign in and receive the papers that they need to fill out, and then go to the teller and then receive the whatever new account that they're waiting for. So the different stations that a person might go through. And in a dentist office, that might be check-in, and then going to have their x-rays done, and then going in for their cleaning, and then meeting with the dentist. So that is again an assembly line of sorts, and it can be balanced. So there's special language to line balancing, there's special techniques to line balancing, and the chapter will lay that out for you. And then there's some homework problems that will allow you to actually experiment with balancing a line. The goal of line balancing is to maximize output and then minimize idle time at the individual stations. Have you ever been in that situation? And I think you could even see this at Chipotle, where there's an assembly line where my burrito shell is warmed up or steamed, and then the meat's put in, and the rice is put in, and the beans are put in, and then all the ancillary items are added to it, and then the chips, and then the checkout. And across that assembly line, you may notice there's people standing around with nothing to do. That would be a really inefficient use of their time. So how could we rebalance that line so that the entire line is operating at the same pace, and one person's not working frantically and the next person over is doing nothing? So it's really to maximize your output by minimizing the wasted time at each individual workstation. It's a little bit different math, but it's kind of interesting. Sustainability is a topic that often comes in here because in our processes there is inefficiency that then creates wasted resources, and today environmentally something we really don't want to move towards. I really like that third bullet. I like to define sustainability as minimizing the net negative impact on the environment that my process or my operation creates. So it can be quite a juicy topic these days. Final one is service blueprinting. This is another way to actually look at from the eyes of the customer. So picture this. Picture yourself going into McDonald's, going through the drive-thru at McDonald's, going through the drive-thru at Starbucks, going into the hair cuttery, going from the customer's perspective. What steps do they experience? They arrive, they're seated. This is a restaurant example that I'm showing here. And then a service blueprinting typically goes through these 4 questions. What's the customer's action? What did they do? Who do they come in contact with? What's going on behind the scenes that the customer might not see but still has impact on their experience? And then what's the support? Often what is the technology that's going on in the background? So it's often an activity that will have you visit a place that you normally do business and actually map that service experience, because the closing, once you have all this mapped out, is to then question, where does the service break down? Where's the customer not get the quality of the product or the quality of the experience that they are expecting? And so we would go through this service blueprint once we have it documented as shown here, and maybe put stars in. It's like, this is where there's problems. The customer's food was cold. Well, here's when they experience it, but when did the problem occur? Why did they get the wrong order? And so this service blueprinting activity allows you to really document from a customer's perspective what they're experiencing and then how things can be improved. So let's dive in and give it a shot this week.